We live in an era when the flights of the legendary Concorde and Blackbird are a thing of the past. But in recent years, a new hero of supersonic aviation has become increasingly visible on the horizon, the X-59 from Lockheed Martin and NASA. This groundbreaking project aims to bring a balance between speed, silence, and cleanliness in a world where even the most innovative aircraft can be rejected by authorities due to environmental risks. The X-59 is not just about breaking speed records, it's about revolutionizing how we perceive and experience supersonic flight. With its advanced design aimed at reducing the sonic boom to a mere thump, this aircraft promises to make supersonic travel over land possible once again. This innovation could reopen the skies for faster-than-sound commercial flights, making long-distance travel quicker and more efficient while addressing environmental concerns. But why is the X-59 one of the most ambitious projects in NASA's portfolio? Join us as we explore the unique features and groundbreaking technology behind the X-59 and discover how it's set to change the landscape of aviation forever. Breaking sound barriers and norms. When you hear supersonic flight, what comes to mind? Futuristic, alien-looking aircraft with bizarre engines? Or perhaps a nostalgic trip back to the Concorde days when crossing the Atlantic took just 3 hours at twice the speed of sound? The Concorde retired in 2003, leaving a void in the hearts of speed enthusiasts. But the desire to travel quickly never faded. Enter a new era of supersonic ambitions. Companies like Boom Technology with their XB-1 Baby Boom and Future Overture airliner, and Hermeus with their quarter-horse, dark horse drones, and Halcyon passenger aircraft are rekindling the dream. These teams, driven by a love of speed, are also collaborating with NASA, which remains a front-runner in aviation innovation. This winter, NASA debuted its own supersonic marvel, the X-59 Quiet Supersonic Technology, QuES-C. But there's an age-old enemy to all supersonic and hypersonic endeavors, the sonic boom. This phenomenon, first introduced to the world by Chuck Yeager in 1947 when he broke the sound barrier in the Bell X-1, was initially a symbol of progress. However, it quickly became a public nuisance. By the end of the 1960s, sonic booms were so irritating that they led to thousands of lawsuits and the eventual cancellation of many supersonic projects. In 1963, President Kennedy's SST initiative aimed to create a commercial airliner that could carry 300 passengers at Mach 3. Yet, public outcry over sonic booms, like the incident in 1968, where a Republic F-105 Thunder Chief broke 200 windows at the Air Force Academy just by flying over, led to widespread opposition. The era of sonic booms brought 40,000 lawsuits, stalling the progress of supersonic travel. Despite this, NASA and Lockheed Martin are on a mission to rehabilitate supersonic travel. Their solution? Reducing the intensity of sonic booms. In 2003, the Northrop F-5E became the first X-plane to prove that aircraft shape could lessen sonic boom impact. As part of NASA's 2-year Shaped Sonic Boom Demonstration, SSBD program, the front fuselage was modified to reduce noise. The X-59 Quest aims to go even further, demonstrating a sonic boom of only 75 dB, about the noise level of a car door closing from 20 feet away or a normal conversation. This is a dramatic reduction from the noise levels of current supersonic aircraft and could be the key to making supersonic travel viable again. Supersonic flight revolution. Imagine a world where the ear-splitting sonic boom is a relic of the past and supersonic flights glide silently through the skies. That's the vision behind the X-59, a revolutionary aircraft designed to change the game. The concept was first unveiled in 2016 when NASA awarded a preliminary design contract to the Lockheed Martin team. Back then, the schedule was ambitious, with hopes of having the new supersonic X-plane take flight by 2020. 2 years later, NASA granted Lockheed a $47.5 million contract to further develop the project. Extensive computer modeling was followed by 3 weeks of rigorous wind tunnel testing on an 8% scale model. These tests assessed static stability, dynamic forced oscillations, and laser beam imaging, building on previous experimental and computational predictions. Feedback was crucial, so NASA sought the opinions of 400 residents from various cities. These individuals endured 1 to 8 sonic booms per day over 2 weeks to understand how these noises disrupted their daily lives. In return, participants received $25 a week for their troubles. To simulate the sonic boom, an FA-18 Hornet performed dives from 50,000 feet, briefly going supersonic to create reduced shock waves over Galveston, Texas, an island, and a stronger boom over the water. Meanwhile, Lockheed Martin's Skunk Works was already making strides, milling the first part of the future supersonic hero in Palmdale, California. By spring 2019, the first large-scale parts were loaded into the assembly tool, and construction began in earnest at the start of summer. The X-59, with its needle-like long nose, stretches 99.7 feet in length and boasts a wingspan of 29.5 feet. From a distance, it resembles a sleek, oversized fighter jet from the future. Despite its lightweight appearance, the X-59 has a substantial maximum takeoff weight of 32,300 pounds, comparable to the F-16 Fighting Falcon's 26,000 pounds and the Swedish Saab JAS 39 Gripen's 31,000 pounds. This metal bird reaches an impressive top speed of Mach 1.5, 990 miles per hour, and cruises at Mach 1.42, 940 miles per hour. It's powered by a General Electric F414 turbofan engine, developed from the F414 used in the Boeing F/A-18E/F Super Hornet, and the F412, initially created for the A-12 Avenger II before its cancellation. The game-changing X-59. Imagine a future where sonic booms are a thing of the past. The X-59 is set to revolutionize supersonic travel, promising to bring us closer to that reality. This innovative aircraft features a top-mounted engine, creating a smooth underside to prevent shock waves from merging behind the aircraft, significantly reducing the power of sonic booms. However, the most significant design challenge was ensuring pilot visibility, given the long, pointed nose cone that obstructs the forward view. The solution? An enhanced vision system, EVS, equipped with a forward 4K camera, offering a 33 by 19 degrees field of view. This system transmits live images to cockpit monitors, effectively compensating for the visibility issue. Collins Aerospace, a subsidiary of United Technologies, was selected to supply the advanced Prime Fusion cockpit avionics, which display the position of the sonic boom on the ground. The EVS 3600 multispectral imaging system, located just under the X-59's nose, will assist with landing, while NASA's External Vision System, XVS, will handle forward visibility. Understanding the importance of cost efficiency, NASA and Lockheed Martin took steps to keep the project economically viable. For instance, the cockpit ejection seat and canopy were borrowed from the Northrop T-38 Talon. The 3-post retractable landing gear came from the F-16 Fighting Falcon, and the control stick was sourced from the F-117 Nighthawk stealth attack aircraft. Additionally, parts of the propulsion system were taken from the U-2 Dragon Lady reconnaissance aircraft, showcasing Lockheed Martin's commitment to resourcefulness. The $650 million question. When you hear the figure $650 million tossed around for the X-59 program, it's easy to wonder, Is this the future of aviation or just a massive gamble? Ambitions are high, but so is the price tag. NASA and Lockheed Martin know that beyond the lofty goals and eye-popping budgets, time is their fiercest enemy. The road to supersonic flight is paved with hurdles, not least of which is securing Federal Aviation Administration, FAA certification, a feat that has eluded many since the supersonic flight ban over land was enacted back in 1973. The clock is ticking. By 2027, the results of citizen flight tests will be reviewed by the International Civil Aviation Organization. This review could potentially reshape the rules for commercial supersonic flights over land by 2028. If public opinion leans favorably and the noise doesn't become a nuisance, the doors to supersonic travel could swing wide open, attracting a new wave of ambitious players to the industry. In the summer of 2023, Lockheed Martin gave us a glimpse of the X-59 emerging from its hangar, and by January 2024, the aircraft was unveiled to the public. The road to its first flight was bumpy, but by May 2024, NASA declared readiness to dive into real flight tests. The focus will be on systems integration, engine startup procedures, and electromagnetic interference before the final testing phase kicks off this summer. So, will NASA and Lockheed Martin succeed in breathing new life into the supersonic dream? Share your thoughts in the comments below. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more updates on the future of aviation. Thanks for watching, and we'll catch you in the next video.